Class. So welcome to the first module, and this is Unit 3, Standard 1, Module 1. It's a horizontally launched projectile, so I can solve for any variable and determine the range and time of the projectile. So go ahead and take out your notes and put this into your notes. You can pause. All right, so now that we have the first thing down, I want you guys to write these next things. So range, what is range? Range is the max distance that a projectile travels in the x-plane. And that's horizontal motion, right? We're talking about what's the total horizontal distance an object travels, time. That's the next one, right? So time is the total time the projectile is in travel. And the last thing is this. A projectile is considered a projectile if only gravity is affecting this object. Okay, so go ahead and write that into your notes. If you need to pause the video, feel free to pause the video. Okay, now that that's in your notes, I want to kind of give you guys an example. So let's go back to this. We did this in class today. So here's this motion, right? So if you were to shoot this cannonball, notice what's happening. As the cannonball is moving from left to right, it's also moving down, right? And gravity's pulling it down. Now, if we add an angle to this, we would shoot this, it goes up, right? And then at some point it goes down. But during that entire motion, it's also going left to right. So we have to consider both planes when we do these kinds of problems. What I mean by that is this. In order to, so let's write that down. So in order to, both planes, both the x-plane and the y-plane need to be considered when doing this problem. Okay? We need to consider what's happening as it's moving left to right and what's happening as it's going up and down. Well, we already know this. In the x, right, horizontal motion does not have gravity involved. Okay, so there's no acceleration in the horizontal motion. No acceleration in the horizontal motion. All right, good. So far, this is what we have, right? Some definitions. What's a projectile? It's an object that only gravity affects. When we do these problems, we need both the x and y plane, and then horizontal motion does not have gravity involved, so there's no acceleration in the x direction. Okay, so let's try this problem here. So a ball is launched, so go ahead and write this into your notes. A ball is launched off a cliff at 15 meters per second. If the cliff is 7 meters tall, determine how far the projectile will go before hitting the ground. So let's think about this. Right? We have a projectile, and this projectile, here's a cliff. The cliff is 7 meters tall. It's going to go from this, right? So here's your cannon, there's your ball. It's going to be shot, and then it's going to fall downward. So it's going to do something like that. Okay, so in this case, right, we're gonna really look for, how far in the x did this travel. Okay, so we really need to do knowns and unknowns. So knowns for the x, knowns for the y. Well, remember, up here we stated one thing. We stated that horizontal motion does not have gravity involved. So the acceleration in the x is 0. Okay, that's the first thing. The initial velocity in the x is 15 meters per second. Okay, that is VIX. There's no acceleration. We don't know what VFX is. We don't know what time is. Let me erase that. And we don't know what distance in the x is, right? So this is really displacement of the x. So we don't know any of those values. Now let's think about the y. We know the acceleration of the y. That's negative 9.8. Okay. Acceleration of the y is negative 9.8. Initial velocity in the y is actually 0 meters per second. It starts, if you look at it when it starts falling down, it's actually not falling down. It's pretty much when it's dropped. Okay. VF, y, we don't know what it is. Time, we don't know what that is. And we know what dy is. This is 7 meters. Okay, so here is the main thing. Okay, when you are working with these problems, there's one main thing you can actually relate, and that is time. The time it takes to travel in the horizontal is the same time it takes to travel in the vertical. Time will be shared amongst these. So if you can solve for time, you can then solve for the rest. So notice, in the y, you have enough variables. You have distance, acceleration, initial velocity to solve for time. You then take that time and plug it into the x. And then you can solve for distance. So the way that works, right, if we look at this equation, distance is equal to VIT plus 1/2 AT squared. We can plug all of our y variables in here, and that's going to give us time. So notice, distance is 7 is equal to initial velocity is 0 times time plus 1/2 times a negative 9.8 times t squared. Okay, good. So anything times 0 is 0. And now you're left with 7 is equal to negative 4.9 t squared. All right. Now notice this 7, because of the ball and because the ball is falling, it should be negative. So divide by 4.9, divide by negative 4.9, divide by negative 4.9, and you get time squared is equal to 1.42 seconds. Now, in order to get time by itself, you're going to have to take the square root. So taking the square root of 1.42, that is going to give you 1.19. Okay. So now that we've found the time, the overall time, we can plug that time into the x. We now can take this time and plug it into the x side. So you have the, if you look at you notice if you use the same equation, distance is equal to VI t plus 1/2 AT squared, you can solve for this as well. Distance, we don't know what it is, but the initial velocity is 15, time is 1.19, and now acceleration in this case is 0, so that term cancels. So you're left with distance is equal to 15 times 1.9. You take 15 times 1.9, you get distance in the x is equal to 17.92 meters. And that is pretty much how you solve horizontal problems. So let's take 20 seconds to recap, right? When we're doing these problems, the acceleration in the x, that will always be 0. Okay, gravity does not affect horizontal motion. This is horizontal. It's not going to affect horizontal motion. What I did is I found my knowns and unknowns. So what was VIX? It was 15 meters per second because it's shot horizontally. The cliff is set at 7 meters tall, means it's vertically 7 meters. So what I did is I broke it down into 2 different components. I used my knowns and unknowns, found a kinematic equation that works with time, solved for time, used time to then plug into x, and solve for distance. So going back again, remember anytime we talk about range, we're talking about how far it went, and remember we need to consider the x-plane and y-plane. We need to consider what's going on horizontally. We need to consider what's going on vertically. And then the last thing is horizontal motion does not have gravity involved, so no acceleration in horizontal motion. All right, that is it. Go ahead and try the next 2 problems, and the module is done. I'll see you guys in class tomorrow.